Hello everyone, myself I am Archana Nandava. Thank you for joining me today. In this video, we will learn column chromatography from basics to the exam-oriented concepts. Whether you are a B.Pharm, M.Pharm or a Pharm.D student, this lecture will help you to understand the topic clearly. So without wasting any time, let's begin. Of the column chromatography. So chromatography is a separation technique in which a mobile phase is carrying a mixture and it will move in contact with a stationary phase. So mobile phase and stationary phases are very important in chromatography technique. There are number of different types of techniques out there in which column chromatography is one of them, and all the chromatographic techniques employ both the stationary phase and mobile phase. Coming to the history of the column chromatography, it was first developed by the American scientist D.T. Wade in 1900. M.S. Wade, the Polish botanist in 1906, used the adsorption columns in his investigation of the plant pigments. Column chromatography is one of the very versatile techniques for the separation of various number of compounds in the nature of solids as well as in liquids. This is also called as a solid liquid technique in which stationary phase is solid and mobile phase is a liquid. The principle of this technique is based upon adsorption. So here a mixture of components will be dissolved in the mobile phase and is introduced into the column. So these compounds are separated based upon their relative affinities, that is attractive level towards the stationary phase. So adsorption column chromatography is also one more name for the column chromatography because we are using a stationary phase called adsorbent material. So this adsorbent material will be packed inside a column and a mobile phase which is of a solvent nature will flow through complete stationary phase and where the separation of the components will happen which are getting retained or adsorbed on the surface of the stationary phase. Here we can call the mobile phase and another name called eluent. So coming to what is the principle again adsorption. So how this works. So the compound which is strongly attracted towards the stationary phase will be retained on the surface of the column material that is adsorbent for a longer period of time. Whereas the other components which are having less affinity or less attraction towards the stationary phase will pass through the column in a very fast manner. Experimental aspects of the column chromatography. The first material is adsorbent or also called as a stationary phase. So usually these are solid materials and they are majorly employed in the column chromatography. And some of the adsorbents are listed here, which are silica, alumina, calcium carbonate, calcium phosphate, magnesia, starch, etc. In this, alumina is generally used for the chromatography because of its less polar nature, whereas silica gel is containing more functional polar groups. So adsorbent should have a following criteria because adsorbent is one of the important aspects of a column chromatography. So the particles should be spherical in shape and uniform in size. Spherical in shape for more absorption and uniform is for without air entrapment arrangement. And it should have a high mechanical stability, it should not react chemically, and it should have a wide range of separation ability. Then it should also be available freely and it should be inexpensive. The common particle size range we will look in for absorbent materials are 50 to 200 micrometers. How to select a stationary phase? So a separation technique works majorly on the success of the technique majorly based on the adsorbent material you are selecting. That is nothing but stationary phase. So first we have to select the stationary phase based on type of technique you are employing. So in case of removal of impurities or how many compounds are getting separated, length of column, affinity, quantity of adsorbent, these are the main factors which will help us to select the stationary phase. Some of the adsorbent materials I have listed here. Based on these adsorbent materials and based on the separation you are employing, we can select the stationary phases. They are divided into three types: weak adsorbent, medium, and strong. When and all we have to use them, I will discuss in short. So when you are separating the impurities, we can have a small quantity of impurity in the sample. So at the time we can go with weak adsorbent. Number of components to be separated, we can use again. Few components means weak adsorbent, more components means strong adsorbent. Affinity, similar affinity, strong adsorbent, different affinities, weak adsorbent. And length of the column, shorter, longer. Based on that, we can select the adsorbent technique as well as the quantity. Now coming to the mobile phase, so this is a solvent or developer. You can call it the different names and everything. So what is the function of this is it acts as a developing agent and it will help us to introduce the sample into the column, and also it removes any pure components. It removes the pure component, that is elements from the column. So how to select the mobile phase based on the polar feature. So always you have to select the solvents based on the increasing order of the polarity nature. Some of the examples, ether, carbon tetrachloride, cyclohexane, etc. Some of these are like we can use them in a mixture or we can use them as an individual solvent. Column characteristic should be made up of a material that will not react with any of the components of adsorbent or as well as with the solvent, and it should have a good capability to withstand the separation time. And column dimensions and diameter were very important. So 10:1, 30:1 or 100:1. So various accessories are attached at the bottom. So bottom of the should be very supportive of the elution process. So length of the column depends upon number of compounds to be separated again, type of adsorbent, quantity of the sample, affinity of the compounds, etc. So long, narrow, wider, shorter, that we can select based on the type of separation you are going to carry out. Then we have to prepare the column with the adsorbent material first. So in this preparation, we have different techniques out there again. So first we have to place asbestos pad or cotton plug or sand at the bottom of the column. Then after the adsorbent material will be packed. So two types of packing are there, dry packing as well as wet packing. So before packing, the column should be completely purified with the solvent or with any other cleaning techniques. Then after that completely dried, then only we have to place a cotton plug or glass wool at the bottom and then fill the adsorbent material. And we have to understand that it should be uniformly filled, that is, there should not be any air entrapment or gap between the particles. So dry packing we can see. So in the dry form of the adsorbent material will be taken and it will be filled into the column. Then after that we can use mobile phase to remove the air entrapment between the particles. See, in the first step, we can see the column is getting filled with the adsorbent material. Then after mobile phase, and you can see there is no air entrapment. So wet packing means prepare a slurry of the adsorbent material with the solvent you are preferably using, and then pour it into the column, and again excess quantity of the mobile phase we can add to remove the air entrapment again. After we can introduce the sample in a mixture form along with the mobile phase into the column. So based on their relative affinities, the sample will get separated. So you can see here in the first picture, the column is ready and excess mobile phase was added so that there won't be any air entrapment. In the third step, you can see where the sample is introduced into the column, and in the fourth and fifth steps, you can see that the sample is getting separated based on its relative affinities, and in the last picture, we can see that eluent is getting collected. So the development technique is called elution. So here elution technique means two techniques will follow: isocratic elution and gradient elution. So isocratic mapping means when we are using a solvent of polar nature, so throughout the separation process we will use the same solvent. Whereas gradient elution means solvents of increasing order of temperature we will use in a mixture or we will be adding in a solvent once. So after this detection, so once they are separated, the elements are collected. How to identify? If it is a colored nature compounds, we can see visually. We can identify them visually and we can mark them or we can check the elements separately. If it is a colorless, we can depend on the TLC. So we can upload the sample on the TLC plate and we can see the separation and then we can quantify. So I hope this lecture is useful. with the basics of the column chromatography, that is history, principle, type of the stationary phase, mobile phase types, and how to select the column, how to select mobile phase, how to select the stationary phase, and what is the experimental aspects. I hope this is very useful. Thank you so much. Thank you for your patience with me.